Let's take a look at the 3.6 homework. Number 6, if triangle HJK, this triangle over here to the right, is equilateral, what are the values of x and y? Well, if it's equilateral, all the sides must be congruent. They all must have equal length. We are told that HJ is 15, which means all the sides must equal 15. So x plus 8 must equal 15. We solve for x and we get x equals 7. Same thing for side JK. All sides must equal 15. So 1/3 multiplied by y minus 6 must equal 15. We add 6 on both sides. 1/3 y equals 21. We multiply by 3 on both sides to isolate y, and we get y equals 63. You can always plug back in to check. 1/3 of 63 is 21. 21 minus 6 is 15. Checks out on number 6. Number 8. This is tough for an early problem. Given that BI, where is BI? BI is down here on the bottom of this figure, is congruent to RD. Where is RD? RD is on the top of this figure. Also, RI, which is the side on the left, is congruent to BD, which is the side on the right. We are trying to prove that angle 3 is complementary to angle 2. Okay, angle 3 is complementary to angle 2. I'll back up. We are given that angle 3 is complementary to angle 2. Excuse me. And we are trying to prove that triangle RIB is a right triangle. So RIB is this triangle on the left here. If RIB is a right triangle, I'm assuming that 1 and 2 are going to be complementary, meaning the sum of angle 1 and angle 2 is going to be 90 degrees. So if I can somehow show that 1 and 2 are complementary, then RIB is going to be a right triangle. If I can show 3 and 1 are congruent, if angle 3 and angle 1 are congruent, then angle 1 and angle 2 must be complementary, because angles that are complementary, back up, hang on, angles congruent to complementary angles, what am I trying to say here? I'll say congruent angles have the same complement or something like that. So if angle 3 and angle 1 are congruent, and if 3 and 2 are complementary, then angle 1 and angle 2 must be complementary as well. All right, so the tough part on this is figuring out, you need to focus on triangle BDI first, this triangle on the bottom right, we'll call it, and focus on the triangle on the top left, which is RID. So triangle RID and triangle BDI. Let's prove those two are congruent. It's pretty easy to see why they're congruent at first. We got BI congruent to RD. We got BD congruent to RI, and then BI is congruent to itself through the reflexive property. So this triangle BDI must be congruent to triangle RID. And then through CP/CTC, angle 1 is going to be congruent to angle 3. So let's look at this in the proof here. BI is congruent to RD, that's given. BI, RD, 1 tick mark and 1 tick mark. RI is congruent to BD, RI, 2 tick marks, BD, 2 tick marks, that's given. And then DI is congruent to DI, that is the reflexive property. So triangle BDI is congruent to triangle RID, side, 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 congruency postulate. Be very careful with your congruency statement. Make sure corresponding parts are in corresponding positions. So let's take a look at this. B is where the 1 tick mark side meets the 2 tick mark side. Well, that's R. R is where the 1 tick mark side meets the 2 tick mark side. So B is first, R must be first. Now I put D second. To get from B to D, I have to travel down this 2 tick mark side. To go from B to D, I have to travel down the 2 tick mark side. Back to R. If I travel down the 2 tick mark side, I end up at I. R down the 2 tick mark side, we end up at I. So if I put D second, I have to put I second. And then how do I go from B to I? I travel down the 1 tick mark side to get from B to I. Same thing in the other triangle, but R down the 1 tick mark side, I end up at D. So I corresponds to D. Make sure you did that properly. Angle 1 and angle 3, they are in corresponding positions, right? BID, that is first, third, and second. First, third, and second, BID. Well, first R, third D, second I. First, third, and second RDI. RDI, that is angle 3. So 1 and 3 are congruent through CP/CTC. Also, we know, back to the given information, angle 3 is complementary to angle 2. Now here's where we get a little tricky with this. I can say angle 1 is complementary to angle 2 through substitution, right? We just said that 1 is congruent to 3, so I can substitute in 1 for 3 and say angle 1 is complementary to angle 2. Substitution. This is not the only way to do this. You could have used that reason I was talking about at the beginning of this as well. I then said that angle RIB is a right angle. Definition of complementary. Let's look at the figure. 1 and 2 are complementary. Therefore, RIB, which is what I should say 1 and 2 make up angle RIB. So RIB is comprised of angle 1 and angle 2. Therefore, RIB must be a right angle. That's the definition of complementary. And if angle RIB is a right angle, then triangle RIB must be a right triangle. That's the definition of a right triangle. Step 7 and step 8, there's a little flexibility on how you work these out. You may not have worked them out exactly as I did. That is okay. There's a few different ways to do this one. You might not be totally wrong if you did it a slightly different way. So use your best judgment. Maybe ask a peer if they think your way makes sense logically and if it flows logically as well. So there you go. Number 8. Number 10. All right, in triangle RST, RS is equal to x plus 7. RT is equal to 3x plus 5, and ST equals 9 minus x. If triangle RST is isosceles, is it also equilateral? Okay, well, let's test it out. If it's equilateral, then all these sides should be congruent. And if they're all congruent, then x is going to be the same in each one of these. Well, if RS equals RT, RS is x plus 7, RT is 3x plus 5. We set those equal to each other. X equals 1 when you solve for x. If it's equilateral, RT is also equal to ST. So RT is 3x plus 5. ST is 9 minus x. We solve for x and we get x equals 1. Okay, so far so good. X equals 1, x equals 1. And then finally, RS is equal to ST. RS is x plus 7. ST is 9 minus x. We solve for x, we get x equals 1. So because x is equal to 1 in all of these, we know it is equilateral. If x were not equal to the same number in all of them, you can plug it in and find out which two sides are equal and determine that it is isosceles. But because x is the same value in all three of these equations, yes, it must be equilateral. X is equal to 1 and all three sides are equal to each other. Number 11. If triangle VSY is isosceles and its perimeter is less than 45, which side of triangle VSY is the base? Okay, so if it's isosceles, perhaps VS is equal to VY. Maybe, maybe not. If it's isosceles, then perhaps VS is equal to SY. Maybe, maybe not. If it's isosceles, then perhaps SY is equal to VY. Maybe, maybe not. We're going to test all three and then determine which situation satisfies this problem, and then determine what side is the base. So first off, if VS, which we're told is 10, VS is 10, is equal to VY, which is x plus 7, we solve for x, we get x equals 3. Once you get the x value, plug it back in to find the side lengths. Well, VS is 10, we didn't have to plug in for that, but SY, take a look at what happens. SY, 2 multiplied by 3 is 6, 6 minus 8, that's negative 2. It's not possible. We can't have a negative side length. So this is not the situation that's occurring. Again, we're testing all three possible scenarios. Hopefully, if we do everything right, only one of them satisfies what we are looking for, satisfies the criteria laid out by this problem. That criteria being the perimeter is less than 45. What if VS is equal to SY? This is another possible scenario. Well, Vs is 10, Sy is 2x minus 8. We solve for x, we get x equals 9. When you substitute in x equals 9, well, Vs is just 10, right? That doesn't change. Sy, 2 multiplied by 9 is 18. 18 minus 8 is 10. So Vs is equal to Sy. That's the way it should have been, right? Because we solved for x under the stipulation that Vs is equal to xy. So 10 and 10. And then you plug in for Vy. That's going to be 9 plus 7, which is 16. Vy is 16. 16 plus 10 is 26. 26 plus 10 is 36. The perimeter is 36 when x equals 9. That satisfies what we're looking for, that the perimeter is less than 45. Let's check the final scenario. It's probably not going to work out, but let's check and see. It shouldn't work out unless the problem was poorly worded or we made a mistake somewhere. But the third scenario is Sy is equal to Vy. Sy is 2x minus 8. Vy is x plus 7. We get x equals 15. You plug in x equals 15 and the side lengths are 10, 22, and 22. You add that up and you get a perimeter of 54. Therefore, this is the scenario we are looking for. Vs is equal to Sy. Well, if Vs is equal to Sy, those are the legs. The equal sides are the legs. Vs and Sy are the legs, meaning Vy must be the base. So if this is an isosceles triangle where Vs is equal to Sy, that means they are the base. Your third side that is not equal must be the base. So Sy and Sv are the legs. Vy must be the base. I might have said that wrong a moment ago, but Vy is the base. Number 12. Given that AB is equal to x plus 3, AC is equal to 3x plus 2, BC is equal to 2x plus 3, and the perimeter of triangle ABC is 20, show the triangle ABC is scalene. So we add all these side lengths together, set it equal to 20. That's how you find the perimeter. Add the three sides together. That is your perimeter. You solve for x and we get x equals 5/2. Okay. Once we have x equals 5/2, we substitute in for AB, AC, and BC. AB, instead of x, that's 5/2 plus 3. 2.5 plus 3 is 5.5. For AC, 3 multiplied by 5/2. 3 times 2.5 is 7.5. 7.5 plus 2 is 9.5. Finally, BC, 2 multiplied by 5/2. 2 multiplied by 2.5 is 5. 5 plus 3 is 8. So BC is equal to 8. It is scalene. AB is 5.5. AC is 9.5. BC is 8. If all three sides have different lengths, the triangle must be scalene. Number 13. The average of the lengths of the sides of triangle ABC is 14. Now, we don't know individual side lengths yet. We'll be able to find them later, but we don't know individual side lengths, but we do know the average is 14. Well, think about if all three side lengths were 14. 14 plus 14 plus 14, that's 28, plus 14 is 42. Is that an average of 14? It is, right? If all three sides are 14, then that's an average of 14. Well, what if we have an average of 14 a different way? Like maybe 13, 14, and 15. 13, 14, 15, those three numbers have an average of 14. Let's add that up. 13 plus 14 is 29. 29 plus 13 is 42. So no matter how you add it up, if the average is 14, then the perimeter is going to be 42. Once we know the average of the sides, 3 times the average, that's going to be your perimeter. So check this out. The three sides added together, x plus 5 plus 2x plus 1 plus 4x minus 6, that equals your perimeter, which we were told is, oh, no, we calculated that is 42. 3 times the average gives you the perimeter, so 42. We're able to solve for x equals 6. Once we know x, now we can find the exact side lengths. 6 plus 5, AB is equal to 11. BC, 2 multiplied by 6 is 12. 12 plus 1 is 13. BC is 13. AC, 6 multiplied by 4 is 24. 24 minus 6, AC is equal to 18. Now the question reads, how much longer than the average is the longest side. So if the average is 14, the longest side is 18. The longest side is 4 more than the average. 18 minus 14 is 4. Number 14. AB and AC are the legs of isosceles triangle ABC. AC and AB are the legs. Remember, the base angles are congruent as well. So ACB and angle 2, they have to be congruent to each other. Look here at angle 3. Angle 3 and ACB, these are vertical angles. So they are congruent to one another as well. How is angle 2 related to angle 1? They are supplementary, right? They form a straight angle, so they're supplementary. Well, if 2 is congruent to 3 and angle 2 and angle 1 are supplementary, then angle 1 and angle 3 must be supplementary. We're told that the measure of angle 1 is 5x. We're told the measure of angle 3 is 2x plus 12. Measure of angle 1 plus the measure of angle 3 is equal to 180. 5x plus 2x plus 12 equals 180. Solve for x and we get x equals 24. We were asked to find the measure of angle 2. There's a couple ways to do this. You could find the measure of angle 1 and then subtract that from 180. Or you could find the measure of angle 3, which is the same thing. Remember, measure of angle 2, where we at 1 tick mark and 1 arc. 1 tick mark, 1 arc. Angle 2 and angle 3, they must be congruent. So you could find the measure of angle 3, and that's the same thing as the measure of angle 2. So that's what I did. 2 times 24. Remember, right here, 2 times x plus 12. So 2 multiplied by 24 is 48, plus the 12. 60 is equal to the measure of angle 3. Therefore, the measure of angle 2 must also be 60 degrees. The same thing would work if you found the measure of angle 1 and subtracted. You would have gotten 120 for the measure of angle 1. 180 minus 120, you still get 60. Either way works. All right, number 16. How many different isosceles triangles can you find that have the sides? How many different isosceles triangles can you find that have sides that are whole number lengths and then have a perimeter of 18? Okay, so whole numbers, perimeter of 18, and isosceles. So it could be 1, 1, and 16. 1 plus 1 plus 16 is 18, right? What's the problem with this? Remember, the triangle inequality theorem states that when you add any two sides of a triangle, their sum must be greater than the third side. Here's the problem. 1 plus 1, not greater than 16. So you cannot create a triangle with sides of 1, 1, and 16. Not possible. How about 2, 2, and 14? That's a sum of 18, but again, 2 plus 2, not greater than 14. 3, 3, and 12. That's a sum of 18, but again, 3 plus 3 is not greater than 12. 4, 4, and 10. 4 plus 4 is 8. 8 is not greater than 10. So again, none of these are possible. We cannot make triangles with these side lengths. Let's keep going. 5, 5, and 8. This is possible. 5 plus 5 is 10. 10 is greater than 8. So 5, 5, and 8, that is one of our triangles. 6, 6, and 6. Oh, Mr. Rivers, that's equilateral. That's okay. Equilateral triangles are also isosceles. This is possible as well. 6 plus 6 is greater than 6, so yes. 7, 7, and 4, that has a sum of 18. 4 plus 7 is 11. 11 is greater than 7, so that's a possible triangle as well. 8 plus 8 plus 2. 2 plus 8 is 10. 10 is greater than 8, so that's possible. And then 9, 9, and 0, but we can't have a side length of 0, so that's not possible. So we have 4 triangles, these 4, 5, 5, and 8, 6, 6, and 6, 7, 7, and 4, 8, 8, and 2, 4 triangles total. All right, that was the last problem on the homework. Thank you very much for your attention.